Okay, students, we are on the last lesson of Mod 1, Topic 2, lesson number 5, page 143, if you're not already there. We're talking about reflectional symmetry and rotational symmetry. Okay, quick review. Identify the opposites of each number. Opposite, another word for that is a negative. You multiply whatever number it is, multiply it by -1 or take the opposite sign. Opposite of -8 is +8. Opposite of 9 is -9. And the opposite of 7 is -7. How do you know that two numbers are opposite when plotted on the number line? The midpoint would be 0. The midpoint of both numbers is 0. Okay, or if I add them together, I would get 0. Okay, go to the next page. Lines of symmetry. A line of symmetry splits it in half, symmetrical. So it's going to ask you about lines of symmetry. Can I split an object somewhere down the middle? And that would be a line of symmetry where it reflects right back onto itself. Okay, whenever we're dealing with a regular polygon, the word regular means equiangular and equilateral. So same angles and same side lengths. Lateral means side length or side, and equa is equal. So equal angles and equal side lengths, those are regular polygons. They use the word regular on the DCAS often. Whenever it's a regular polygon, the answer is always, for how many lines of symmetry, it's whatever the number of sides are. So it's 5 sides. A regular pentagon will be 5. A regular hexagon, 6. A regular octagon, 8. Okay, and you usually have one of those questions on the DCAS. It's going to use the word regular, like I just gave you those examples. Okay, so a circle has an infinite amount of them. And where I draw a line through the center, so if it asks how many lines of symmetry does a circle have, the answer is infinite. Okay, if it's not a regular polygon, it may not have any. Okay, anytime it's regular, it's got the exact same number of sides. Okay, so I did this star here. That would split it down the middle. Okay, in that spot, that would split down. There's 2, 3, 4, 5. Okay, 5 lines of symmetry right there. And notice there's 1, 2, 3, 4, 5 star piece, I guess if you want to say it goes out. Okay, go to page 146. Reflectional and rotational symmetries. A plane is reflectional symmetry if you can draw a line so that the figure to one side of the line is a reflection of the figure on the other side. That's what we just got in talking about. We were just doing those examples of reflectional symmetries. Recall that a line that you drew on each shape is called a line of symmetry. So reflectional symmetry means you have lines of symmetry. Each of those lines you drew on there was called a line of symmetry. I already told you, again, reviewing, the word regular means equilateral and equiangular. Which shapes have reflectional symmetry? Any regular polygon is going to have reflectional symmetry. And remember, it goes by the number of sides. It says consider an equilateral triangle. Equilateral triangle, it's also equiangular, which means it's a regular. They don't usually call it a regular triangle, but that technically is what it is. They usually just call it an equilateral triangle. It has 3 lines of symmetry because, again, it has 3 sides. As I told you, that's what the rule is. Now, what I was explaining here is rotational, dealing with rotational symmetry. So let's get rid of that till we get to that. Okay. So here's where we're talking about rotational symmetry down here. A plane figure also has rotational symmetry if you can rotate the figure more than 0 degrees, so that means it does not include 0, but less than 360, and the resulting figure is the same as the original in the original position. So between 0 and 360 degrees are my only possibilities. It does not include 0 and 360. This is a DCAS question as well. They're always going to deal with regular polygons, or a circle would have an infinite amount of, okay, but regular polygons. And all you've got to do is, on a regular polygon, is do 360 divided by the number of sides, or number of angles. Okay, that gives you that answer right here gives you the first rotational symmetry for that object, for that polygon. So for example, if I have a square, we know a square has 4 sides and 4 angles, so 90 degrees. If I rotate a square 90 degrees, it comes right back onto itself. And then it's that many degrees each time. 90 plus 90 is 180. 180 plus 90 is 270. 270 plus 90 is 360, but remember, it can't include 360 or 0. So the rotational symmetries, plural, for a square is 90, 180, and 270. Now it says, what is the rotational symmetry? Singular, it's always the first one only. So if they use rotational symmetry, it'd be every 90 degrees. If they say, what are the rotational symmetries, plural, it'd be 90, 180, and 270. And you can just do that for any one that you wanted here. Can a shape have both? Yes. Okay, because all regular polygons have reflectional and rotational symmetry. Okay, all regular polygons have both. And that's usually what it's always asking on the DCAS of some regular pentagon, regular hexagon, regular octagon, regular decagon, 10-sided, regular dodecagon, 12. Okay. And remember, for the rotational piece, it's just 360. So say it was dodecagon. That's got 12 sides. That means every 30 degrees, it would rotate back onto itself. If it's a rotational symmetry, that's the first one, 30. If I wanted the symmetries, I just add 30 each time until I got up to 360, but I don't include that one. 180, 210, 240, 270, 300, 330, but again, I don't include 360, so I'm done. That'd be for a dodecagon, 12-sided. Okay, regular dodecagon, that is. These are all we dealing with regular. Okay. Consider these shapes right here. That's a regular octagon. REG for that, and octagon 8 sides. So it's got 8 lines of symmetry, and then for rotational symmetry, 360 divided by 8, which is 45. So every 45 degrees, it rotates onto itself. This one is not regular, so I actually have to find it. There's only that one right there, line of symmetry right there. There is no rotational symmetry at all. I can't rotate any amount of degrees and have it come back right onto itself. Here's an equilateral, also called a regular triangle. So it's got 3, because it's regular, 3 lines of symmetry, and the rotational symmetry is 360 divided by 3. So every 120 degrees, 120, 240, the next one will be 360, but remember, you do not include 360. So rotational symmetry, singular, 120. Rotational symmetries, 120 and 240. And that's not regular, it's a rectangle, but that's not regular. Regular would be a square for a 4-sided one. So that you've got, halfway there, horizontal and vertical. Okay. And then rotational would be 180. If I rotate 180 degrees, it would rotate back onto itself. Okay. Here's just identifying symmetry with letters. Can I draw a line of symmetry that's going to reflect it right back on itself? Yes, right there. Yes, right there. Yes, right there. And right there. Yes, right there only. Okay. Which letters have vertical but not horizontal? Okay. So it has vertical. M does, and but no horizontal. B only has horizontal. H has both horizontal and vertical. And X has both. Okay, so the only one that has vertical but not horizontal is the M. Okay, so that's with those. You can practice more of those if you wanted to right there. Okay, test the pattern you notice on a regular pentagon. I've already told you, in a regular hexagon. Okay, reflectional symmetry, same number. So pentagon has 5, hexagon 6. Rotational symmetry, remember I do 360 divided by the number of sides, 5. That's 72 degrees, every 72 degrees. The next one will be 144. Then add 72 to that. If it just says symmetry, the first one is 72. Here we do 360 divided by 6, and every 60 degrees we'd have rotational symmetry. 60 being the first one, add 60, 120, 180, 240, 300, and we don't include 360. Okay, that's the pattern I want you to see. Okay, so that ends that lesson, rotational and reflectional symmetry. This is good to remind yourself, isosceles right triangle. Isosceles means at least 2 congruent sides. There's my 2 congruent sides. Since those are the same, both of these have to be 45 degrees. So this is called a special right triangle, 45, 45, 90. Special right triangle, which you'll get into later. There's special rules on the lengths of the sides of a 45, 45, 90. Special right triangle is what we call it. Okay, that's just practice. All right, that goes ahead and ends it right there.